All right, let's see. So I know everyone's here paying attention and not screwing around in the back of the room for some reason. So let's see. So class.
Yes.
Roberto. There we go. All right. So remember, we're pretending like we want to be here. So pretend like you're excited to be here. Okay. Yes. There we go. See, just like that. That works. All right. So this one right here, I kind of messed up on the title of this. This is actually supposed to be titled "Motion in Two Directions," but when I went to go save this, it did not save my file I was currently working on. So life goes on. But I will need assistance with this because I need you paying attention. You will need calculators. Yes, please go ahead. You need calculators. You will need them. You will need them. And I'm going to ask you people randomly to please put stuff in the calculator. So the act of putting it in the calculator is going to be part of your practice. Because a lot of people are incorrectly adding things to your calculator. So they're getting wrong answers and don't know why. Oh, my notes. Thank you. Oh, thank you. I am blessed. Okay. Now, we had Anna volunteered as tribute for my picture right here that I did. So, projectile. Any object which projected by some means and continues to move due to its own inertia. It's a good photo, right? All right. I should put glasses on, but you know the thing that hit you in the head, you knock off the glasses. Anyway, so I know you guys are paying attention. So this is wrong. This I don't know. My board's messing up, so it's when I go over. It's skipping some slides, so I need you guys to actually try to make sure. So this should be the next slide, right? Yeah. So since a projectile moves in two dimensions, it therefore has two components, just like a result vector, horizontal and vertical. So now if you look, in this case right here, my magnitude, my velocity going to the right, they're all the same. They're all the same length. So the length of that is my magnitude, how much that is. So it's all going to the right. There's nothing acting against it. Now, going up, it is going up here. Why is it going up, and why is my length of these smaller? Why is the y component at changing length? It's getting higher. It is getting higher, but what's also happening? Think of it the y direction. What is happening here? Think of Newton's law. What's Newton's law say? Give me the whole thing. Everything that goes up must come down, right? So in that sense, why must it go down? Gravity. So I have velocity going up, and so as it's going up, what's happening? Something's pulling it back down. So as it's going up, it's slowing down as it goes up. When it finally stops somewhere right about here, it stops moving up, and it changes direction, and it starts going down. So, because gravity is pulling it down. So even though the velocity was going up, my initial went up, it started pulling it back down. Okay, so that's the different components that we have. So we have gravity acting against it, pulling it down always, where I have a continuous velocity in the horizontal direction, because unless there's something acting against it, it's not going to change. So anyone know the other law for that one? There's a law for that one. Anyone? So we talked about Newton and gravity. So why is this one going to keep going to the right? You guys, why not it in science class? No? Perfect. There it is. See? Do you remember where you learned it, or is it just like Discovery Channel? You saw watch a TikTok on it? No, I am not kidding. That's the number one thing that a lot of students actually tell me. Oh yeah, I got it from TikTok, or I got it from some short or some Vine or something. Yeah, something they saw on the internet, or was it actually in a class? You don't remember? Okay, so objects in motion tend to stay in motion unless acted upon in a another direction. So something else that's going to act upon it. All right, horizontal velocity component never changes. Covers equal displacements in equal time periods. This means that the initial horizontal velocity is equal to its final horizontal velocity. So my V initial is the same as V final. Magnitude of these. So they keep going. They keep going in this direction at the same magnitude. And the y direction is the one that has something acting against it. That's my gravity. So horizontal velocity stays constant. Y, object in motion tend to stay in motion unless acted upon in other means. All right, so gravity does not work horizontally to increase or decrease the velocity. So gravity only acts upon the y direction. It doesn't act upon the x direction. That's what that means. Is this the next one? Okay, good. So vertical velocity component changes due to gravity, does not cover equal displacements. So equal displacement means the spacing between each of these are not going to be equal. So if you notice, as you get down here, they're even longer. So does not cover equal displacement in an equal time periods. Both magnitude and direction change as the projectile moves up. The magnitude decreases. So as it goes up, where's the button? I have a button for this. There. As it's going up, magnitude is decreasing. So the length of that line is decreasing there as we're going through this. And its direction is upwards. As it moves down, the magnitude increases and the direction is downward. So let me, there we go. Come on now. Wait, I should already have thought there it is. Okay. So this is what that means. So if it's going up here, so my y direction going up, so it gives me a positive velocity and a negative gravity. Because gravity's pulling it down, right? Velocity's going up, gravity's going down. What can I tell about these signs? These signs are different, right? Different signs. So positive velocity going up, gravity pulling it down. I know that this is going to be slowing down. And this goes back to when I was trying to explain to you about the sign changes for my velocity and acceleration to tell if it's actually going to be increasing or decreasing because of that. So my velocity going up, my acceleration, remember gravity is acceleration. Gravity is acceleration. So it is actually pulling it down. So when the signs are different, it's going to be slowing down. Now from here, from this point right here, I have my velocity changes. So I'm going to have a negative velocity and gravity is not changing. So gravity is negative. So I have a negative velocity and a negative acceleration. The signs are the same. And in this concept right here, we can look at it and say, what do we know about it as, from this point right here going down? What's happening? What do I know about the object as it's going down? If it goes straight up to here, and then what happens after that? It starts. Is it increasing or decreasing? Increasing. So gravity is pulling it down. You know what you're. Yeah, I know. I know you know what you're saying, but like saying it right. So gravity's pulling it down, right? So at this point, it stops going up. It starts going down, but it starts going down faster and faster as we go. So negative velocity, negative gravity, it is speeding up. All right. Did I skip a slide? I did, didn't I? Did I still skip a slide? This one?
Yeah.
Okay. I don't know, my button's acting weird, so it's starting to mess up. Anyway, combining velocity components. Together, these components produce what is called trajectory path. This path is parabolic. What's the word parabolic sound like? It should be similar to a map. Parabola, right? Parabola. Okay. So, yeah, so it's the shape of a parabola. So if it's that in nature, what do we know is going to happen right here? What's going to happen right there? That is my very good. That's my vertex. And what do I know about this particular vertex? If it's an upside down parabola, what do we know about this vertex right there? That point right there is going to be the. I almost heard what you said. Louder, please. Tangent? Change? Yeah, that is going to be a change. It's going to be changing velocity, right? So it's going to change velocity, but what about the height? What do we know about the height right there? Is that going to be the highest point? Yeah, that's going to be my maximum height. And so I'm going to get maximum height out of that, and I know my velocity here is equal to 0. Because at some point I have positive, 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 0, and it always has to go to 0 before it changes direction. It goes back to negative, negative, negative. It goes down to negative there. Is this the next one?
Yeah.
Okay, good. All right, there we go. All right, so acceleration components. Gravity is acceleration. If you notice the magnitude on all these, acceleration, my acceleration is all the same length. My magnitude is the same size, so that means they're all the same. Gravity is going to be constant. Now, theoretically, technically, we say gravity is constant, but is gravity actually constant around the Earth? There's actually no. There is places in which that gravity is different. So there is a big low gravity point in the Indian Ocean, which is kind of neat to know about. And because of that, the water level is lower. So there is a spot in the ocean where you would think would be a big flat surface, but the water level is actually, the top of the water, sea level is lower than surrounding areas because there's not the gravity pulling that down. So it's kind of weird, but still need to know. Anyway, common mistake is to think that acceleration at the top of the trajectory is zero. Acceleration is not. Acceleration is going to be constant. Gravity is never zero in the vertical direction. So it's always going to be pulling down. It's the right one? Yeah. All right. Horizontally launched projectiles. Projectiles have no upper trajectory and no initial vertical velocity. So that means that I'm going to throw it straight forward. It's got to go straight forward. Okay. There is no vertical component. It's just going straight forward. But then because of that, I also have acting upon that, I have acceleration due to gravity, which is going to start pulling it down as we go through here. So my velocity initial in the y direction is going to be 0. Where velocity initial in the x direction is going to be constant. So that means it's going to stay the same all the way across this. So the magnitude of each one of these is going to be the same. So they're all the same length here. No. You guys don't get to see my artwork. It's skipping slides. Okay, this is the right one. All right, horizontally launched projectiles. So we're going to make a formula out of this. To analyze a projectile in 2 dimensions, we need 2 equations. One for the x direction and one for the y direction. And for this, we use kinematic number 2, which is going to be my delta x is equal to, I have my initial velocity times time, plus I have 1/2 gt squared. But there's, oh wait, hold on. I forgot one piece. It doesn't actually pertain to this, but it doesn't pertain specifically to this because we're starting at, wherever we start with this. So now starting this out, we're going to have my different directions. So I have the vertical component and I have the horizontal component. My horizontal component is going to be, that's going to be equal to my initial velocity times time. And the other piece I'm working with is going to be my vertical component. And my vertical component is due to my gravity, which I'm going to have my delta y is equal to 1/2 gt squared. All right, remember velocity is constant horizontally. So it means that the acceleration is going to be 0. So horizontally, 0 acceleration, so it's going to be constant, stays the same. Remember that since the projectile is launched horizontally, initial vertical velocity is equal to 0. So I'm going to have 0 for my initial first part. And it's the only part that's being acted upon it is the y direction. So do we have these down? Because I'm going to need to actually use this for the next problem. Let's see. Hopefully it's the right one. Yep. All right. A bullet is shot horizontally from a shoulder height, 1.5 meter, with an initial speed of 200 meters per second. How much time elapses before the bullet hits the ground? And how far does the bullet travel horizontally? All right. What do we know? And we're going to have to, you have to label these with the direction to go along with it too. So with the X and Y, what do we know? The height, right? But we don't call it height. What do we call it? Okay, so in which direction? That's going to be your what? Very good. So as you're talking about, yes, height means up and down. So my Y position. So that one right there is going to be, it's going to end up, because I'm trying to get it to hit the ground. So it's going to be, my Y initial. Okay. There you go. What else do I know? Initial velocity, but you gotta give me directions. So remember, this one is a horizontal, so it's only going that way, right? So this is gonna be for the, yeah. So it is going to be initial velocity of X is 200 meters per second. Yes? No, maybe? Okay, so part A, what are we looking for part A? Very good, and that is letter T. Part B, what are we looking for part B? Huh? Yeah, which displacement? Okay, the bullet, but remember, we're talking about two directional. So my displacement for what? For X, very good. So it is my displacement for X. So that is my delta X. So when I say we have to label and be specific on what it is that we're talking about, this is what I'm saying. All right, so let's see. My initial height is my initial height is 1.5 meters. And what is this ending height? It's going to be 0, right? What is my delta Y? What's my delta Y going to be? What is my displacement for my Y? I started at 1.5 and I end at displacement means what's the change from my start to my finish? What is my delta Y? It's just 1.5, right? Because I'm ending on the ground, so the ground is 0. It's so it makes my math a lot easier when it is ending at 0. So whatever my height is, my change in height is going to be from there to 0. So that's my height. Alrighty, so my first one I'm looking for is my time. So I'm going to use that formula that was given. So time is my Y component. So that was my delta Y is equal to 1/2 GT squared. Now, this is important. I'm going to do the algebra first. So I'm going to show you the algebra to do this. What variable am I looking for? I'm looking for t, right? In my first part, I'm looking for t. I'm looking for my time. So what would I do to that 1/2? What did I do to that 1/2 to try and get it away from the right side of my equation? Multiply both sides by 2. Multiply by 2 to cancel that out. And so now I'm going to have 2 delta y is equal to gravity times squared. Now what do I do? Divide by g. Very good. So I get 2 delta y divided by gravity is equal to time squared. And how do I undo a square? Got a square root. So it's going to be time plus or minus the square root of 2 delta y divided by gravity. Do I ignore one of those? I have 2 answers there. I ignore one of them. Which one do I ignore? Negative, because time cannot be negative, right? Now, what I did here is by doing the algebra first, you now have a formula for time. You don't have to go through and plug it in here and solve it every time yourself. You now have the formula for time. So for those people actually taking notes and writing this down, you now have the formula for time. Everyone else that you're perpetrating like you're paying attention, okay, now's a good time to pick this up and actually write it down. So let's go through what I have. So for my formula, I have my time is equal to the square root of 2 times 1.5 divided by my gravity, which is 9.8. Plugging it into your calculator is going to be key. Now, I guarantee you there's going to be people having issues with this and not get the right answer. Because they're not plugging it into the calculator, because you need to practice plugging it into the calculator. Tu calculadora es muy importante. Please, please, please plug it into the calculator. Now, so my time . 0.553 seconds. Anyone not get that? Anyone not get that? So I can help you with the calculator. I'm going to show you on here because a lot of people struggle with this and no one wants to say anything. Calculator. I'm going to go and I'm going to start by going math. No, actually, let's do the square root first. So second, square root. Now inside that square root, I'm going to put a fraction. So that's going to go math over here to fraction where it says n divided by d. So numerator divided by denominator. And so I could actually enter it like this. So I can enter it exactly how I do it mathematically, which was 2 times 1.5 over 0.8. There you go. Hopefully that should help some people. If you have trouble with that, make sure you write a note about that in your thing. Yeah. The problem is if there was a plus sign right there, it would be incorrect. So instead of 2 times, if it was 2 plus, that would be incorrect. You just got lucky because the calculator did orbital operations correctly there. But if there was a plus there, it would do it incorrectly. Okay. All right, so we got part A. Part B, I'm looking for my delta x. So part B, I'm looking for delta x. How far does it travel horizontally? So that's going to be my delta x formula. So delta x was equal to my initial velocity of x times time. So my change in x, my initial velocity was 200 meters per second. My time, 0.553. So my x, my change in x, my displacement is 110 point. What are my units? Yeah, no, it is delta x, but what are my units on this? M, just meters. Because it is a change in x. It's not a related rate, so it's not a distance over time. It's not meters per second. It's not acceleration, which is meters per second squared. This one is going to be from start to finish. It's 110.6 meters away. Hopefully that's a little bit helpful. All right, so that being said, I'm going to try and leave you people right here. You guys actually have the assignment, which is going to be due on Monday. So I'm going to give you the rest of the time in class. Please work on that. Or even better, if you did not turn in the other assignment that was due yesterday, please try and get it to me today. Right when? Yeah.